Our topic is safe and reliable. We designed a PSQ network named SOHS. This is our group member. Let's start with introduction. We mainly want to design a healthcare network, and this network is very special. It's a value-based healthcare. We simply say it is a kind of human-centered design network. They need to analyze a lot of data, EMR or kind of like that, to give better care for the patients. So it means we need to design based on the data transfer, data collection, data storage, and safety. So let's start for the next part.
Here's the analysis and the specification document. The first one is initial conditions, type of network project, scope of architecture and design, initial design, architectural goals, and outside forces. The following one is requirements, specification, map. There are many different specifications. For example, the user may access the service from the office or home. And the map describes the distribution of the whole network. The network is distributed in 4 sites. Each site comprises of a complete LAN, which includes servers, storage servers, external access servers, and firewalls. The external users could access the services through internet, and the data of the whole system is saved in outside cloud every 5 minutes. Following is the flow analysis. There are 4 types of different flows. The first flow is the flows between 4 office servers. The second flow is the data migration from the inner city office primary storage server to Roseville second storage server. The third flow is the external access, and the fourth flow is the data archival and internet access. Different flows have different performance requirements. For example, the first flow requires 100% reliability and 3 Mbps capacity. This type is guaranteed.
Okay, thank you very much. In this part, I'm going to introduce the architectural models and the addressing and routing architecture justification. We select 2 architectural models. The first one is the topological model, and the second one is hierarchical client-server model from the flow-based model. There are 4 of the flow-based models. The reason why we choose this one is, firstly, it supports the multiple location. Second, it ensures a high availability. Third, it handles access from the outside. The last one is we can set a robust backup solution based on the hierarchical client-server model. The IP address distribution is quite simple. The basic logic is that we borrow 2 bytes from the host address, which is 00, 01, 10, and 11 for each 4 areas as it shows. And we choose the OSPF as the routing protocol. In this network, there are at least 1,000 IP addresses. So RIP does not satisfy the need. Eventually, we choose the OSPF. The reasons are the numbers of the devices are growing, and the database could link together. And also, we could synchronize the database through the link state advertisement. Also, it supports the VLSM CIDR, which ensures we will make full use of the IP addresses allocated. The shortcomings are it's really hard to set up, and it needs a really high performance CPU, and it needs more experts to maintain it. We select the DMZ, demilitarized zone, as the routing boundary because of security and external access. The DMZ is actually a exterior gateway protocol set between 2 autonomous systems. In this case, it's the system between the 4 LANs and the metropolitan networks. The external IP addresses access. There are many ways to realize this function, but we select 2 of them. The first one is the port forwarding. It's redirects traffic from the external IP to the internal IP, which is in the local area network. The advantages are it's really simple to set up, and it's cost effective. The shortcomings are it's not secure enough. Once the single point fails, it's gonna affect the whole function of the network. However, the DMZ is much more secure than the port forwarding. Every external access needs a DMZ approval to access the external database, and DMZ connects all LAN together. It's really good for maintenance. Thank you very much.
Today we are going to talk about network management agriculture classification. First one is business management layer. This is where we keep track of all our main tasks, like scheduling doctor's appointment is very important because we all know we need our network to be up and running, and our data need to be safe. The second one is service management layer. Here we make sure to our online service, like video chat with working smoothly. The third one is network management layer. This is where we look at how the network is doing overall. We are always check every point in network to make sure everything is working right. The last one is the element management layer. This part is crucial. It's where we keep an eye on our basic network devices like routers and firewalls. The scheme of devices, what are we talking about? The main pieces of our core routers, switches all over the place, edge routers and firewalls, just so you know, our main routers is over in our CNA office. One thing we are always watching out how the network's doing. We look at how fast things are going if we are dropping any information and how much of our network is being used up. And we are doing this every 13 seconds to catch problem fast. For all the monitoring, we use something called SNMPv3. It helps us get really detailed information about our network devices. They have got two main ways to keep an eye to devices. One is the real-time alerts from our device, and the other is about looking at trend and the big picture stuff over time. And when we need to make changes, we need to use SNMP to optimize setting for whole process, and SSH if we need to get really detailed. Lastly, we collect some information. We should keep the data safe and always making backup so we don't lose anything important.
Let's look at the performance architecture justification. Starting with architectural considerations, we ensure our design is in requirements alignment and adheres to our goals. Importantly, it supports the right environment. For performance mechanisms, we highlight quality of service, resource control, and the trustworthiness of our service level agreements. Discussing internal and external relationships. Efficient data flow is achieved through end-to-end and per-hub scheduling. We have integrated performance and addressing routing for smooth operation. And crucially, we optimize both performance and security.
Okay, let's talk about security and privacy plan. As healthcare-oriented network design, the security and privacy is very important. So we list several objectives for network security, as we can see here. The ensuring the patient data, maintain data intelligence and availability, comply with law and institutional rule, both doctor and patient confidentiality in data, which is very important because the VBHC network design requirements. So we list the technical requirements such as 5 points, data encryption, access control, data backup for the platform and the client's availability running, network security, and the privacy control. The physical level based on the technical requirement analyzes the access key activities, IRG or dynamic password check, which is two-step check, and stock absorbing and firefighting measuring, which is physical measuring, to keep service and all the machine safety and climate control for equipment. Machine normally will not make mistake, but people will. So we need to list simple people control parts, which is vendor must be made security and standard, regular security environments for patients, which is security environment check, environment security training for all the stakeholder who need to visit the key data, which is important privacy data like EHR, EMR, or such as public health data, and regular security and backup during.
Okay, thank you. I will introduce this part. As it shows from the diagram, we have 4 local area networks in the Sydney, Roosevelt, Dodge Hill, and Metroville. Each network has servers, external servers, and backup database. The central servers function even in maintenance because other servers will play their roles. The sequential maintenance will be 24/7. And the unified external firewall for all 4 networks, the outside is the DMZ. And the devices in each local area network was not listed one by one because, as we discussed, they maybe add more devices into different local area networks. It's going to be very complex if we list them all. So we just list the crucial part of that. The IP addresses has been elaborated before. As we can see that the internal IP addresses is more than the external IP addresses. So we encourage the users to use more IP addresses in the network rather than the external IP addresses. It's only for the emergency use. Thank you. And we will introduce the next part.
Let me introduce you to design traceability. It serves as a foundational guideline linking our design intentions to actual implementations. We analyze architecture to best merge the requirement for scalable and secure network and the interoperability requirement. When it comes to architecture to design decisions, we always consider how everything fits together. Our key approach is a layered model. This ensures everything is organized and easy to management. Moreover, our top priority for us is a requirement for security to ensure safety for all users. Moving on to our problem analysis, we recognize several challenges. Problem 1, slow access to electronic health records. Problem 2, insufficient speed for data backend and recovery. Problem 3, network congestion due to multiple access. Problem 4, security concerns with remote access. So how do we measure success through our design metrics? This covers everything from technical specifications, capacity delay, and RMA, but also variety user needs ensure seamless data transfer, uptime, and optimum resource allocation. And of course, device requirements with emphasis on capability, performance consistency even under performance under load, and the emphasis on interoperability.
Here's the life cycle consideration. The first one is operational stability. It has network performance monitoring are those 3 holds: immediate notification, issue resolution, and documentation. The second one is supportability. We need to build infrastructures to support the whole system. It requires data center, network infrastructure, remote consultation, and authentication and security. The last one is confidence. Confidence requires reliable patient data transfer without loss, high quality remote consultations, secure integrity of patient records, support for real-time remote surgical guidance.
In conclusion, we designed a network that complies with VBHD standard based on the strategy network design process, from analysis to planning, architecture design, and IT device to the final life cycle planning and the documents. We hope we can help these clinics more in the future.